We have one more rational equation to solve before we leave this section. So after we solve, we will identify the numbers that we have to exclude as potential solutions. And remember what that means is any number for x that would give us a 0 in the denominator of a fraction is a number we would have to exclude as a solution. You can't have 0 in the denominator. For example, 2 over 0, that's not even a real number. So we have to make sure that none of these denominators would have a x value that gives them a 0 in the denominator. All right, after that we're going to figure out which of the three types of equations this is. Identity, conditional equation, or an inconsistent equation. All right, well let's go ahead and start. The first thing I want to do is multiply this by the least common denominator. I don't know what the least common denominator is by looking at this. The first thing I need to do is factor all of the denominators, each one of them individually. So I'm going to rewrite this equation below, and 4 over, and I have to factor this denominator. So it's going to look something like this. And I know I need an x and an x. And then two numbers that multiply together to give me a negative 10 means I have a plus and a minus. And those two numbers have to add together to give me a positive 3. So I think the number 5 and a minus 2 would do it. 5 times negative 2 gives me negative 10. If you add 5 and negative 2, you get 3. And you could FOIL this out to verify that these two are equivalent. Next one. 1 over x plus minus, because this term is a negative 6. So it looks like if they need to add to a positive 1, I would use a positive 3 and a negative 2. And then on the right hand side, I've got 3 over make that a little better. Let's see, x, once again a plus and a minus. They have to multiply to negative 12. I think a minus 4 and a positive 3 would do it, because you'd add together and you'd get a negative 1. So all we did is rewrote this into an equivalent equation, which is this, but we factored the three denominators. What that allows us to do is easily determine what the least common denominator is. The least common denominator, probably don't have enough room to write it out all the way there, so maybe I'll put it up here. The LCD is every factor listed down in the denominators has to be part of the LCD. So I have to have x plus 5 and I have to have x minus 2. I have to have x plus 3 and I have to have x minus 2, but I also already have x minus 2. I don't need to repeat it. That's x plus 3. And x plus 3, which I already have, and then x minus 4. So that's my LCD. I could put it over 1 if I wanted to. So normally I write it right next to it here, but I kind of ran out of room, so I'd have to squeeze it in there. So I need to multiply this LCD, these four terms multiplied together, by every one of the three terms in this equation. So when I consider the first term, this x plus 5 and the x minus 2 are going to cancel out with this x plus 5 and x minus 2 and leave us with x plus 3 times x minus 4 times that number 4. So 4 times x plus 3, x minus 4. That's again what we get when we multiply the LCD, this whole term, four factors multiplied together. When we multiply it by this fraction, these two of these factors cancel out and leave us with the 4 on top and the remaining two factors that did not cancel. Minus. Let's see, the x plus 3 and x minus 2 are going to cancel out. 1 times x plus 5, x minus 4. All right, and again, this coefficient is really a negative 1. Minus, and then 1 is the coefficient, so I left that off. Equals 3 times something. The 3 comes from there. X plus 3 and x minus 4 cancel right with these two. And we get x plus 5 times x minus 2. Just like that. So, what we just did is called clearing the fractions. We started with a rational equation, multiplied it by the least common denominator of all of the denominators, all the fractions, and now we have a simple algebra problem to solve. So let's continue. First thing I'll do is take the 4 and then FOIL out these two terms. So I would get an x squared minus 4x plus 3x. That's minus 1x minus 12. And then I FOIL out these two terms to get x squared. Minus 4x plus 5x is plus x. 5 times negative 4 is minus 20. But now if I leave it like this, I'm going to get the wrong answer. This minus is in front of this whole term. So I need to put parentheses around that term, which really means this negative sign is going to get distributed with this term and this term and this term. So it basically means we change the signs of everything in the parentheses. Equals 3 times. FOIL this out to get x squared. Minus 2x plus 5x. That's plus 3x. 5 times negative 2 is negative 10. So now we'll just simply do nothing but distribute all three of these terms. So 4x squared minus 4x minus, let's see, 12 times 4 is 48. Minus x squared minus x plus 20. Oops, I don't need the parentheses anymore. I distributed the minus sign through these three terms. So everything changed. That became negative, that became negative, that became positive. Equals 3x squared plus 9x minus 30. All right, well, actually there's a simple thing we can do right now. Let's look at just the x squared terms. How many x squareds do I have on both sides? Well, I've got a 3x squared on the right. On the left-hand side, I've got 4x squared, and I've got a negative 1x squared. If you combine those together, you get exactly 3x squared. So if we subtract 3x squared from both sides, that goes, that goes, that goes. So now we have a more simplified equation to work with. This is negative 4x, and that's negative x. So that's going to give me a negative 5x when I combine them. And then this one and this one, when I add those together, negative 48 and 20 is a negative 28. So that's the left-hand side. And the right-hand side is just 9x minus 30. So I will, let's see, do I want the x's on the left or on the right? I guess I could go ahead and subtract 9x. I'll put the x's on the left. So the right-hand side just becomes negative 30 because those cancel out. Negative 5 and negative 9. That's negative 14x minus 28. Add 28 to both sides. And what do we get? Negative 14x equals negative 2. So divide both sides by negative 14 to get x by itself. And that cancels to give us x equals, well, negative and negative cancel out. And then 2 over 14 is 1 over 7. So we believe that's the solution. We do need to go back and make sure it's not one of the numbers that needed to be excluded as a potential solution. So up here, after we factored, it's easy to determine the exclusion or exclusions. X cannot equal any number that would give us a 0 in the denominator. If x is a -5 or a +2, this would be a 0. -5, it cannot equal +2, it cannot equal -3, and it cannot equal, I've already got 2, -3, or a 4. Those are the 4 numbers that could not possibly be the solutions. So 1/7 is none of those, so that is actually our solution. And one final question that was asked is, do we have an identity, conditional equation, or inconsistent equation? Well, as I mentioned earlier, almost everything is going to be a conditional equation. 95 or more % of our equations will be conditional because it'll have a solution. It might have 1 or 2 or 3 or 4 solutions, but it will not have an infinite number. All real numbers will not work, usually. And in this case, it is not the case that we have no solution. So this is conditional. Conditional equation. And I'll let you plug in 1/7 to verify that this is a true statement. And my goodness, that would be a lengthy thing to check. X squared is going to be 1/49 plus 3/7 minus 10. I do know it's the correct answer. This would take us quite a while to verify, though. So I'll leave it at that.